So there's there will most likely, or it's very probable that you come across a scenario where you have to make your own points. I will say most of the time the points are given. You just have to put them into L1 and L2. Figure out which regression you have to perform. Again, most of the time they tell us which regression to perform, so you don't even have to, that's no guesswork there. And then you just create your equation and answer some questions that follow, perhaps even a graph, okay? Now, this type here on page 52 is the scenario where you may have to find that extra point that is missing. 52 is just, it's a model. It's kind of like, it introduces a way of thinking using the symmetry of the parabola to help you find points that you need. You need at least 3 for a parabola. So we had at first, we're starting on the ground. We are given some sort of indication that we reach a maximum, the highest point, something like that. So the vertex is given, and so we have to find that last one. And so we use symmetry. We know that if it takes 1.25 to get to the middle, it'll take another 1.25 to get to this one here. Okay, so multiplying that x value times 2 gets you this. This is the one that most students, they get this one. Where I see a lot of mistakes is this scenario where you're given, you're not on the ground, you're starting somewhere off the ground, you reach the highest point, and then a lot of students want to go here for some reason. They want to go to the x-intercept and find that point because, hey, that's, after all, that's what we do. But remember, you want to have, you know what, I'm going to say this, it's kind of like a semicircle. You should be focusing on a semicircle. So for example, if you're starting off the ground, you reach the top, now you're gonna focus on the point that's immediately across your starting point right here. Okay, so you kind of have that little semicircle up here, and since it takes us 3.5 to get to the middle, it'll take us another 3.5. So in a sense, we just multiply that by 2 to get that point outside. Okay, so that's 7, 8. Remember, if it's 8 here, we're back to 8 at some point. Does it mean that it stops here? The action doesn't necessarily stop there. We've just used these 3 points to come up with 3 points we need along the path, and then figuring out, for example, how long this object stayed in the air, or where does it land from its starting point, something like that. That's up to you to find later on, okay? I'm just going to tell you this. If I ask you for this, or if the question asks you for this, chances are you will have to find it using your equation. Why am I saying that? Because a lot of students go, oh, this one is 7, 0. Because they figure out, oh yeah, I got to multiply it by 2, and they think it's this one. It's wrong. They come up with the equation. And so now there's a part B. It's like, how long did it take for this object to hit the ground? You'll have to say 7, 0 again. You already found that point in A. Why would you have to do that again in B? So that's another way to figure out, wait a minute, this cannot be, right? So keep that in mind. Resist that temptation. That's one scenario where you have the starting point, the high point, and then you have to find a third one like that, going across. Then these two here focus on, they give you the start and the end. They give you a little bit of information of the vertex, like the highest point, like the highest elevation or altitude. You have to figure out this value, the x value. Well, we know that these ones are right across from each other in this scenario, so we can just divide it by 2 to get the 4. And now you have your vertex. Now you can perform a regression. Same here, we have a scenario where we go down a ramp, we hit a low point, then we go back up. We're focusing on these 3 points here. And since we have the start and the end given, we divide it by 2 to get this 25 here, and then we have enough to come up with our equation. Okay, so I just wanted to mention that. We'll do an example on 53. Let's go to 53 here. I didn't do 53 in the notes, did I? In the video. Yeah, that's what That's what I figured. So let's go to 53. I'm telling you this already. I'm just going to do A and B. I'm not going to do graphing. I'm not going to do any of that. Sometimes when I'm ambitious, there was a time where we didn't have an exam during COVID, so we could do more in class. So that's why I have like extras here. So I'm just going to focus on the skill of coming up with the 3 points and your equation. Because after that, those skills you already know how to come up with extra points, or how long does something stay at a certain height or above. You know, something like that is already kind of what you've seen. So let's go to 53 and read this and come up with our equation here. So Roger would like to recycle his beverage container. He throws his container up from a height of 1.75 meters. So he throws up, sounds wrong, throws this container up, right, at a height of 1.75 meters, and estimates that it reaches a maximum height of 2.8 meters after 0.75 seconds. I will argue that because of the wording, greatest, maximum, something like that, that is giving me the vertex. Okay, I'll just say that, right? That's pretty straightforward, and we kind of understand that when we throw something, it follows a parabolic motion, a path. And so the container, however, lands on the rim of the recycling bin. That is probably worth noting here. Doesn't land on the ground. It lands on the rim of the recycling bin. The bin is 0.6 meters tall. Okay? Determine the quadratic equation that models the path of the container. Make a sketch. I think sketching is the best way to get started on these ones. And we have time, and we compare that to the height of the container. We're not starting on the ground. We're starting somewhere off the ground. And that is 1.75, right? And then you throw this up, and it will land somewhere. Okay, it doesn't hit the ground. So we'll stop there for now. While I do my attendance, I'm going to tell you already, I'm giving you more information than what you need in this case. While I do my attendance, I want you to come up with this point, and the third point will be across where you started. Are you able to come up with these 3 points by yourselves? Well, I already gave you one. You need 2 more. Okay? So I'll pause there for a bit. You go and... All right, so 1.75. Did you have a question? Okay. And then we know this point, and please don't mix this up. Time is first, right? So 0.75, 2.8. So make sure you don't mix that up. And then this one, I know I'm going back to 1.75. And since it takes me 0.75, you always, the vertex always kind of represents the middle of the whole parabola. Since it takes 0.75, it'll take another 0.75. So this is 1.5 here, right? You're in a sense, you multiply that by 2 to get there. And you might ask yourself, what about the 0.65? What about the bin? The bin is somewhere here, right? Somewhere below the 1.75. But we don't know how long it's going to take to get there yet, right? So too much information. We don't need it. We don't need it in this case. If you have a starting point and you have a vertex, fold it, right? Fold the parabola to figure out this part. So now we're going to do the equation. So I go time and height. I like to write out the points. It really shows you, let's see, whether you're doing it right. And I don't know if you notice, 1.75, I'm back to 1.75. I go L1, L2, stat, calc, quad reg, and Let's do the, let's perform the regression, stat edit. Don't forget how to do this because it's going to be used a lot. Regressions are not going anywhere. Stat calc. Oops. Try this again. Quadreg. You got to go second 1, comma, second 2, comma, alpha trace, paste it into y1, and there it is. That's my equation. So it's negative 1.87 x squared. Don't forget the variables, plus 2.8x plus 1.75. Yeah. Like this? I would say whenever you use your calculator, just give me a keystroke. Tell me what you pressed. That's the safest. All right, how long does it take for the beverage to reach the rim of the recycling bin? So now we're interested in this, right? So again, I'll just do this. Forget about the 3 points. We already now know we can model this path, but we know that it lands somewhere here. Okay, so what is the x value when the height is 0.65? That's basically what it's asking for. So if we have a y value, what do? y2, 0.65, second trace, intersect. I'll show you how to do it. I don't even know if my graph is going to show up on my screen. I should have done that first. Not a good screen. So I'm going to do zoom standard. It's still not the greatest, so I'm going to get rid of all the negative there, just -1 and -1 for my mins. That's pretty good. So I'm just going to find the intersection. My cursor is going down, so I'm going to go left now till it shows up. There we go. Enter, enter, enter. This is 1.82 seconds. Okay? So that's how long it takes to get to the rim. Is that marketplace? I know because I just posted a few things. Nintendo Switch, anybody? Not now. How about, I don't want you to forget about this one. How long does the container remain below 2.5 meters? I know that this is 1.75, so it does something like this. And so 2.5 meters is going to be somewhere here. That's my 2.5 line. If I give you a y value, just graph it, right? For reference, I'm going to change my window even more. I don't want all this dead space here. I will go y max. The highest I get is 2.8. So if I make y max 3, then that's that. And I will also get rid of this dead space here. X max, I'm going to bring it down to 5. That's better. Wait a minute. This is not right. 2.5 there. There we go. Oops. See what I did there? Watch out. I typed over it, but then it kept the 5 that was already there. So I'm going to clear that, go again. So that's my 2.5 line. What am I interested in? I'm interested in time below, right? So how would I approach this? How would I do this? If I find these intersections and I subtract them, what would I find? Time above. Because, right, between these two times, if you subtract them, where is the blue line? It's above it. But we don't want that, right? We want below. So what I will do is I will find the time above, and then I will subtract it from this time. Because remember, it gets thrown, it's in the air for 1.82 seconds. So I will just subtract this time up here, right, from the total flying time, and that gives me the time below 1.82. Does that make sense? Sort of? Sort of? We'll get there? Well, let's try this one more time. I'll try this one more time. I hope that you understand that I have to find these 2 points right here. Right? So how about we start with that? This is time 1, this is time 2. Let's find those. Let's find those. Second trace 5. I'll find the second point first because it's closest to where I was at. So I'm just going to go 1.1509, like 4 decimal places. Second trace 5. Repeat that. This is 0.3491. If you subtract these 2 numbers, think about what happens between those 2. You're above the 2.5 meter line. So technically time above is going to be 1.1509 minus 0.3491. This is most likely what you're going to encounter, by the way, but I can never just let it go, right? I can't just keep it basic. I always have to take it a step up, right? Some of you love it, some of you hate it. Right? Let's rephrase it. Most of you hate it. I get it, but I'm trying to prepare you for something I don't know it's coming your way. Okay? So this is time above. Because whenever you find intersections and you subtract those times, you're going to find whatever is in between those 2 points. Okay? So how about highlighter? Highlighter is even better. Okay? We want time below. I'm going to go 1.82, which is straight from the previous question, minus 0.8018. That's 1.02 seconds. That's what they ultimately, that's what we wanted. Could you have found from here to here, find that time, subtract, right? And then find from here to here, subtract, and then add those? Yes, you can do that as well. Yeah. Final answer. Yeah. So when you find your equation, if they want more than 2, they will say it usually. So let's say you rounding to 2 decimals means you're going to go 0.00. They don't want that. So they'll ask you to round to 3 decimals. But other than that, it's 2. Money has to be 2. Everything else can be 2 or more, as long as you do it correctly. Yes? If this question had said, how long does a container stay at or above 2.5, this would have been enough. When it says below, then for me, it was less work to find this and then subtract it from the total flying time. That was my approach. Does that make sense? Just read carefully. And I think it's not totally unfair because I already asked you to solve for the total flying time, right? We knew that. So now it was just like, oh, well, let's find those times for sure. Let's subtract those. What happens between those 2 points? It's above it. Well, that's not good enough. It's not it, right? This is not it yet. You're close. You're getting very, very close, but you need to subtract it from total flying time. Okay? Okay, I'm going to stop there.